get this. Imagine, like, trying to recreate the universe.
Wow.
Or at least a big chunk of it inside a computer.
Yeah.
Sounds kind of crazy, right?
Yeah, like science fiction.
Totally. But hold on, because scientists are getting closer to actually doing that. And that's what we're diving into today, the Frontier supercomputer and this, it's groundbreaking simulation.
That's pretty amazing.
Yeah. All of this comes from this Live Science article. It talks about how scientists are using Frontier to model the universe's, like, the whole evolution. And we're not just talking about gravity, right?
Right.
This simulation goes way beyond that.
Yeah.
Includes stuff like dark matter, gas, plasma.
All the good stuff.
Yeah, all that complex stuff between the stars that usually gets left out.
Definitely.
So to help us unpack all of this, we've got our expert here to break down just how monumental this is. So Frontier is, like, it's being hailed as this massive leap forward. And the article says it's the second fastest supercomputer in the world, capable of 1.4 exaflop PS. Now, I'll admit, that sounds more like a made-up word than an actual, measurement.
It's a mouthful.
Could you help us, like, what does that even mean?
Well, so think of it this way. Past simulations, they were kind of like looking at a cosmic skeleton. They could show the basic structure of the universe,
Right.
how gravity pulls galaxies and stars together, but they were missing all the detail and the interactions of matter and energy.
Okay.
And this is where Frontier is so different. It can perform 1.4 quintillion calculations per second.
Whoa.
So not only can it simulate the large-scale structure of the universe, but it can also, like, see those smaller processes that are happening inside galaxies, like how stars form, how black holes evolve.
So it's not just simulating a bigger chunk of the universe.
Yeah.
It's like simulating it with way higher resolution, seeing those little details that were just impossible before.
Exactly, yeah.
That's amazing. And I understand that this is all thanks to, like, a particular kind of simulation that they're running on Frontier called hydrodynamic cosmology, which, again,
Yeah.
another
So long one.
big word. Can you tell us more about what that is?
Yeah, so hydrodynamic cosmology, it goes beyond just looking at the gravitational interactions between objects.
Okay.
It actually considers how things like dark matter, gas, plasma, all that stuff that fills space between stars and galaxies,
Right.
how they move and interact with each other. It's like, imagine, like, looking at a map of the city versus experiencing that city in, like, full 3D.
Oh, I like that. That makes sense.
Yeah.
So we're going from a basic roadmap of the universe to something like, Google Earth.
Yeah, exactly.
Where you can zoom in and see, like, individual neighborhoods, or in this case, maybe individual stars and planets forming.
Yeah, exactly. And to get that level of detail, Frontier uses the special software, HACC it's called, which stands for
Rid of that.
Hardware Hybrid Accelerated Cosmology Code.
Okay.
The team, they actually spent like 7 years developing this specifically for this simulation.
Wow, 7 years. That's some serious dedication.
Yeah.
And all that effort, it resulted in a simulation that runs way faster than anything they've ever done before, right?
Right. The article said it ran almost 300 times faster than previous simulations that they ran on, I think it was called Titan, a different supercomputer.
Oh, wow.
And the speed increase, it's crucial because it lets researchers not just simulate a larger part of the universe, but to run the simulation, multiple times. Okay. With slightly different starting conditions.
So it's not just running one big simulation. It's like running thousands of experiments all at the same time. That's got to be a game changer for scientists.
Yeah, it really is.
Trying to understand, like, how the universe actually, evolved.
Yeah, because they can compare the results from all these different simulations to what we actually see in the universe.
Right.
And use that to, fine-tune their models and really get a better grasp on how things work.
Okay, so we've got this crazy, powerful supercomputer running a super detailed simulation of the universe. And it's running at, like, warp speed.
Yeah.
It's super impressive, I gotta say. But I have to ask, like, what's the point? What are scientists hoping to actually do with this thing?
So it's not just about creating, like, pretty pictures of space.
Okay.
It's about using the simulation as a tool to, like, investigate some of the biggest mysteries in cosmology.
Like what?
Like, for example, one of the big puzzles right now is dark matter.
Right, dark matter. It's like we know it's out there because of its gravity, but we can't actually see it. It's like the invisible scaffolding of the universe.
Exactly, yeah.
Holding everything together, but we don't really know, like, what it is.
Right, and that's where the simulation comes in.
Yeah.
By comparing the dark matter distribution in the simulation to, the real universe observations, they can test different theories about what dark matter actually is.
So it's like this giant cosmic laboratory where they can run experiments on dark matter, change different variables, and see how that affects how the whole universe evolves. That's incredible.
It's pretty cool.
That's a powerful tool.
And it's not just dark matter either. This simulation can also help scientists understand other, complex phenomena too.
Like what?
Like how galaxies form and evolve, how black holes behave, even just the large-scale structure of the universe.
So it's really about, deepening our understanding of the universe on, a really fundamental level.
Yeah.
This isn't about just taking cool pictures. It's about gaining real insights into how everything came to be.
Exactly.
And those insights, could they have implications for other areas of science as well?
Oh, absolutely. Think about things like particle physics, astrobiology,
Wow. This is opening up a whole new chapter in our understanding of the universe.
It is, and it's just the beginning. As supercomputing technology, keeps advancing, we can expect even larger and more complex simulations down the line.
It's mind-boggling to think about, what's possible. We're entering this era where we can not only observe the universe, but experiment with it.
Yeah.
In these virtual labs.
Exactly, yeah. And who knows what we might find, right?
I'm hooked. This is so fascinating. But I'm curious, aside from, testing those theories about dark matter and understanding how galaxies form, are there any other, practical applications that might come from this simulation?
Yeah.
What can we learn about our own little corner of the universe?
Oh, that's a great question. So while this simulation, it does focus on the large-scale evolution of the universe, the insights that we get from it can be applied to understanding our own galaxy, too.
Okay.
The Milky Way.
So,
What does it tell us about our solar system?
Yeah. So by studying how stars and planetary systems form in the simulation, we can get a better idea of how our own solar system actually formed.
Oh, wow. So we can basically rewind the clock and see how, our sun and planets were born.
Pretty much, yeah.
That's so cool. And not only that, by looking at how gas and dust behave in the simulation, we can also learn more about the processes that create those habitable planets.
So we might even be able to use this to search for other Earth-like planets, ones that could support life.
It's possible, yeah. By studying what conditions create those habitable planets in the simulation.
Right.
We can identify the regions in the galaxy where those planets are most likely to be.
Okay.
And that can guide future observations and, space exploration missions.
This simulation is it's multifaceted. We're not only looking back in time to see how the universe began, but we're also looking forward.
Yeah.
Searching for clues about the future of our own planet and the possibility of life elsewhere.
It's pretty amazing, and it's all thanks to the power of supercomputers.
Yeah.
It really shows how technology is allowing us to push the boundaries of, scientific discovery and just, explore the universe in ways that we never thought possible.
It's like we've been given this amazing new tool, like a virtual time machine. That lets us peek into the past and maybe even glimpse the future. I can't wait to see what other secrets this simulation will unlock.
Me neither.
Yeah.
It's really an exciting time.
Yeah, this is amazing. I think that's a good place to pause for now. We've covered a lot already, but there's still so much more to explore. I can't wait to dive back in with you in our next segment.
Yeah, it really is remarkable, how far we've come in our ability to model and understand the universe. Makes you wonder, where do we even go from here? What are the next steps in this whole, cosmic exploration journey?
It's a good question. This simulation is clearly a huge leap forward, but what's next? Are there even bigger, more powerful simulations on the horizon?
Oh, absolutely. As supercomputing technology just keeps advancing, we can expect to see even larger, more detailed simulations in the future. Imagine simulations that can incorporate even more complex physics, like the behavior of black holes or the evolution of dark energy.
So we're not just going to be simulating a larger part of the universe. We're going to be simulating it with even more precision, like factoring in all these different variables, all the complex forces at play. It's like, we're constantly adding more pixels to the picture, getting a clearer and clearer view of the cosmos.
Exactly. And with each, increase in resolution, every time we add a new layer of complexity to these simulations, we're bound to uncover like new mysteries, new questions that we didn't even know to ask before.
And it's not just about size and complexity. There's also the question of, like, what kind of simulations we can run. I mean, this one's focused on the evolution of the universe, like, as a whole. But could we eventually simulate, like, entire galaxies in detail, or even, like, individual star systems?
That's definitely a possibility. As our understanding of, astrophysics computational techniques improves, we'll be able to create more specialized simulations that focus on, specific objects or phenomena. Like imagine a simulation that could accurately model like the formation and evolution of a black hole or the collision of two galaxies.
Oh, wow. It's
Yeah.
like having a cosmic zoom lens, allowing us to focus in on these incredible events and study them in ways that are just, like, impossible with just traditional observational astronomy. And speaking of pushing boundaries, the article did mention that Frontier is also being used for other things besides simulating the universe. Can you tell us a bit more about that?
Of course. Exascale computing, it has applications in a ton of different fields. Think like climate modeling, material science, drug discovery, even artificial intelligence.
So it's not just about understanding the universe, it's about using that knowledge to solve real-world problems here on Earth. Like, we're taking those lessons from the cosmos and applying them to our own backyard.
Exactly. For example, like in climate modeling, these supercomputers, they can be used to create these really detailed simulations of Earth's climate system. And that can help us to, better understand the impacts of climate change and come up with strategies to, maybe mitigate or adapt to it.
And in material science, I imagine they're being used to, like, design new materials with very specific properties, maybe stronger, lighter materials for building spacecraft, or like more efficient materials for capturing solar energy.
You're absolutely right. Exascale scale computing is already leading to like breakthroughs in materials design and discovery. And in medicine, you can use these supercomputers to simulate the complex interactions of molecules, which can help with things like developing new drugs and therapies.
It seems like there's almost no limit to what this technology could be used for. It's really quite remarkable. And it all stems from our human curiosity, our drive to explore and understand the world around us, both the vastness of the universe and, like, the intricacies of life here on Earth.
That's what makes this such an exciting time to be like a scientist. We're living in this era of like just unprecedented discovery, and exascale computing is one of those tools that is really driving that progress.
It's definitely inspiring. But as with any, like, powerful technology, it's important to use it wisely and responsibly.
Hmm.
We need to make sure that the benefits of exascale computing are accessible to everyone, and that it's used to address the most pressing challenges facing humanity.
I completely agree. The ethical considerations around powerful technologies like this, they are crucial. It's our responsibility to make sure that these advancements are used to benefit society as a whole and not to, make existing inequalities worse or create new ones.
That's a really important point. It's easy to get caught up in the excitement of all this scientific discovery, but we have to stay mindful of those potential consequences, and use this technology in a way that benefits all of humankind.
Absolutely. And I think that's a key takeaway from our deep dive today. The universe is full of wonder and mystery. And as we develop these more powerful tools to explore it, we got to do so with both a sense of awe and a sense of responsibility.
Well said. And this brings us back to that incredible simulation running on Frontier. It's not just a technological marvel. It's like a symbol of our scientific ambition and our desire to understand our place in this whole cosmos.
Yeah. And it's a reminder that, we're really just scratching the surface of what we can achieve. Imagine like what the simulations of the future will be like, the mysteries they'll unravel, the questions they'll raise. It's a really exciting time to be alive.
I couldn't agree more. This deep dive has really, like, opened my eyes to the incredible possibilities of exascale computing and what it means for our understanding of the universe and, like, our place within it.
It's been great exploring these ideas with you, and I hope our listeners are feeling just as, inspired and amazed as we are.
Oh, I have no doubt. But before we wrap things up, I have one final question for you. This simulation is obviously a game changer, but I'm curious, like, what do you think the most significant impact of this kind of technology might be in the long run? Like, what's the big picture here?
That's a really interesting question. In the long run, I think the most significant impact of like exascale computing and these kinds of simulations, it's going to be a fundamental shift in how we do science, how we like approach scientific discovery. We're kind of moving from this era of observation to an era of like experimentation, but on a cosmic scale.
So instead of just like looking at the universe and trying to figure out how it works, we can now create these virtual universes,
Yeah.
like these sandboxes where we can test our theories and run experiments and see how things actually play out.
Exactly. It's like, we have this universe-sized laboratory right at our fingertips. We can change the parameters, the initial conditions, and just see how those changes, affect the evolution of that virtual universe. We can explore things that would be impossible to actually observe in the real universe.
It's like we're becoming cosmic architects, designing and testing different models of reality to see like which ones actually fit the universe that we see.
Yeah, in a way. And as these simulations get more sophisticated, as we're able to incorporate more of the complexities of physics and cosmology, the line between what's virtual and what's real, it's going to get blurrier.
That's a fascinating thought. I mean, at what point does a simulation become so real that it's like indistinguishable from actual reality?
Right. That's a big philosophical question that we'll probably be debating for for years to come.
Yeah.
But I think it really highlights the potential of these simulations. They're not just tools for scientific discovery, they're tools for understanding like what's possible, what reality even is.
It's like we're entering this new age of exploration, not just of space, but of like the very nature of reality.
Exactly. And as we go deeper into this, this uncharted territory, I think we need to approach it with a sense of wonder, with curiosity, but also with humility.
Yeah, absolutely. Well said. This brings us back to this incredible simulation running on Frontier. I mean, it's not just a technological marvel, right? It's a symbol of our ambition as a species, and our desire to truly comprehend our place in this vast cosmos.
And it's a good reminder that we're just, that we're at the very beginning. Think about what the simulations of the future will be like, the mysteries they'll unlock, the new questions they'll ask. It's a really exciting time.
It really is. This deep dive has been like truly mind-blowing. We've gone from the power of supercomputers to the philosophical implications of simulating reality itself. I mean,
It's been a pleasure, exploring all these ideas with you. And I hope our listeners are, walking away with a new appreciation for just how much is happening in science and technology right now and the big questions that it's raising about our place in the universe.
I have no doubt that they are. This simulation, it's a testament to human ingenuity, to our curiosity, our drive to explore. And who knows what other incredible discoveries await us as we, continue to push those boundaries of knowledge, keep exploring this vast unknown. So everyone listening out there, keep exploring, keep questioning, keep looking up at those stars. The universe is full of surprises, and with each new discovery, we get a little bit closer to understanding our place in this grand cosmic tapestry. Until next time, keep diving deep.